evaluate the surface integral over the surface of a cube bounded by the coordinate planes and the planes x equal to y, x equal to z, x equal to a. So here we are going to use the divergence theorem in Cartesian form, right? The Gauss's divergence theorem. So by Cartesian representation of Gauss's theorem, we have this surface integral to be equal to the volume integral of partial derivative of first component with respect to x, that is x cube minus yz, plus partial derivative with respect to y, the second component, minus 2x²y, plus partial derivative with respect to z of this third component, that is z. That's it. And here we write dx, dy, dz. And now we are going to put the limits for x. It is given to us that x equal to y equal to z equal to a. That is, we are taking the limits of x to be from 0 to a, for y 0 to a, and also for z 0 to a. As we are having the planes x equal to y equal to z equal to a. That is x equal to a, y that is the plane x equal to a, y equal to a, and z equal to a. Three planes are given to us. So according to this, we have taken the limits for x, y, and z from 0 to a, right? Okay. So this is equal to the volume integral of derivating this with respect to x, we get 3x² plus derivating the second component with respect to y, we get minus 2x² plus derivating the third component, we get with respect to z, it is 1 dx, dy, dz. 3x² minus 2x² is x² plus 1. So this becomes 1 plus x² dx, dy, dz. So now integrating this integrand with respect to x first, we get x plus x cube divided by 3, right? With limits from 0 to a. So this is double integration from 0 to a. And this is x plus x cube divided by 3 with limit 0 to a, dy, dz. Putting the upper limit, we get a plus a cube by 3 minus, putting the lower limit, we get 0. So this becomes a plus a cube by 3. And now this integrand is a constant. We can take this outside of the integrals. And integrating 1 with respect to y now. So that is y with limits from 0 to a, dz. Putting the upper limit, we get a minus lower limit 0. So this becomes a. So a is again a constant. We can take this outside of the integral. So this becomes a cube divided by 3 plus a into a, and integration from 0 to a 1 dz. Integrating this 1 with respect to z, we get z with limits from 0 to a. Putting the upper limit, we get a, and then minus lower limit 0. That becomes again a. So this becomes a square now, a cube divided by 3 plus a. Or we can write this as a the power 5 divided by 3 plus a cube. This becomes the required solution for the surface integral. Thank you.